Let's begin. Today is January 11th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 5, 8, 15, 18, 21, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute largest. Should triangle be the largest? Should square be the largest? Or should circle be the largest? Criteria card D, again, takes a look at our 3 digits, triangle, square, and circle, but this time we'll add up the 3 digits, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card E, again, takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure. Specifically, there are 2 scenarios. One where there is a pair in our solution, as in the example 131, or alternatively, there are no pairs, but there are 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F, again, we'll take a look at our 3 digits, from triangle to square to circle, and the Turing Machine will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, or should they appear in a descending order, basically decreasing, as in the example 421, or do they have no order? Let's take a look at the example 231. Notice it goes from 2 to 3, it increases, and then it goes from 3 to 1, decreasing. Of course, you could have a code that's decreasing and then increasing, but really it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, there are other examples of 3-digit codes that exhibit no order, but they have one characteristic, and that is that if you have consecutive equal digits, that can also exhibit no order. So let's take a look at criteria card B's example of 112. Notice the ones. They are consecutive, meaning that they are next to each other, and of course they are equal. So the reason I state that that's an example of a 3-digit code that has no order is because when you go from that first 4 to that second 4, there's no change. So it neither increases nor decreases. And that's one of the attributes of, if it's to be ascending, it's got to be increasing. If it's descending, it's got to be decreasing. If there is no change, then that's another way to define a 3-digit code as having no order. Now remember that the objective of today's puzzle is to find that 3-digit code that abides by all of the 6 criteria cards we just described. And we are going to start off with an initial proposal of 314. So the first thing I'm going to test is criteria card A. Okay, so the Turing Machine does approve of my choice in triangle. I did pick an odd 3, and the Turing Machine confirms that yes, that triangle value should or is odd. So let's go ahead and type that up in our notes in section A, and we'll just state that triangle is an odd digit. And of course, since it is odd, let's go ahead and cross out the 2 evens. Okay. The next thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my proposal. And criteria card D, we are adding up to 3 digits. Well, let's go ahead and do that. So 3 plus 1 is 4. 4 plus 4 is 8. My sum total is 8. But since the Turing Machine does not agree with that, it's informing us that the sum of the 3 digits should actually be odd. So let's go ahead and type that up in our notes in section D. And we'll state that triangle plus square plus circle should be an odd quantity. And so what can we say about that? Well, we already established that triangle is odd, and if we want the sum total to remain odd, it seems to me that there are 2 possibilities, and that is that square and circle have to be of the same type. So either they're both going to be odd or both are going to be even. And the reason for that is that whenever you add 2 digits of the same type, whether both even or both odd, that sum total, or that sum thus far, would be even. And then when you add up the odd triangle digit, that would result in a sum total that would be odd. So we're looking at a possible odd, even, or an all odd solution. Nothing to cross out, but something to just keep in mind. Let's see. Let's go ahead and test criteria card C next. Okay, so the Turing Machine, so criteria card C is evaluating which one's the largest. My largest digit in my proposal is circle, but the Turing Machine does not agree with that. So that means that the largest either has to be triangle or the square digit. So let's go ahead and type that up in our notes in section C. And we'll say that triangle or square is the largest. So let's see, is there anything we can cross out knowing that? Well, I think we can definitely say that circle can't be 5, because if circle were 5, there'd be nothing for either triangle or square to be, since they are to be larger. One of them's supposed to be larger. So yeah, so we know for sure that circle cannot be a 5. And let's see, is there anything else? Yeah, I think that's it. Let's see. Yeah, we have a triangle that or square that can be 5s, and those would be bigger. Let's see. Yeah, I don't think there's anything else we can cross out. Okay, well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B, querying how many 1s there are. And it's still outstanding as to which is the largest, triangle or square. We did not test criteria card E, learning a little bit about the structure, whether there's a pair or not. And we also didn't test the ordering. Now, I did defer testing criteria cards E and F to the second round, and that's because from previous puzzles, we have learned that you can actually deduce both of them. So the argument goes as follows. If I were to say, presume that a 3-digit code is ascending, meaning that they're increasing. Now, I may not have stated this earlier, but they are uniquely increasing. You can't have equal consecutive digits like I mentioned at the top of the video. they have to be ever increasing. So if you presume that a 3-digit code is ascending, then that would automatically mean that there are no pairs because they are uniquely increasing. So there's no opportunity to pair up. And if that's the case, that would make this card, criteria card E, irrelevant in that scenario. And the same happens if it's a descending solution because it's uniquely descending. There's no opportunity to pair up. So again, making this criteria card irrelevant. So we can actually state that we can deduce that the solution must have no order. So let's go ahead and type that up. Okay, and we can make an argument similarly if we presume that you have a pair. Well, if you take a look at the example, consecutive pairs will have no order for that fact that I mentioned, that there's no, it neither increases nor decreases. So by definition, it would have no pair. And that would be the same if it would end in consecutive pairs. There's no change. Now, what if the pairs were, the first and the last, basically triangle, circle? Well, that would exhibit, depending on what the actual digits were, it's either going to be increasing then decreasing, or it could be, again, decreasing then increasing. And as I stated, as in this example, there is that shift from one direction to the other. So any kind of pair, regardless of where it's at, exhibits no order, making this criteria card irrelevant. So for that fact, we can actually deduce that the solution should have no pairs. They should all be unique. Well, yeah, and I'll mention something in a second. Let me just type up that we're going to deduce that the solution has no pairs. Okay, I was about to mention that, well, there are two cases, but 222, the same digit repeated, regardless of which one it might be, that, of course, that exhibits no order because, well, there is no change from those digits. So, yeah, so they do have to be uniquely distinct. There should be no pairs, all unique. Okay, so let's think about that for a second. Does that help us? Well, remember again, we are looking for either odd, even, or an all odd solution. So from that standpoint, no, it doesn't really inform us whether we have pairs or sorry, not pairs, I apologize, evens or odds in square and circle. Now, what's interesting about criteria card B, well, at this point, there can't be 3 ones or 2 ones. Either there is a 1 or there isn't. Now, if there is no 1, that is actually very interesting. Because if there is no 1, regardless of where it would go, you can say, then you'd have, 3 and 5 available to you. Well, if you have 3 and 5, that sum so far would be even, and you'd have to have another odd. But if you can't have ones and you can't have duplicates, then that wouldn't work. So, in general, if you have no ones, that forces square and circle to be even. Now, so the possibilities are, if there is a 1, it can still be an all odd solution or pairs. But if there is no 1, then that forces it to be only square and circle to be even. And so I'm thinking that that's what might happen. So I'm actually going to do an odd, even proposal. Since we already established circle is not even, or sorry, I apologize. I'm sorry, triangle is odd. So square and circle would have to be even. And we already established that circle is not the largest. So I am going to, let's see, we're looking for the largest, so that would mean that I kind of lost my train of thought. Sorry about that. Circle's not the largest. Triangle and square. Oh, I apologize. These are both evens. Well, is that possible? Let's see. It could be, yeah, it could be that if they're both to be even, and what if we say square is the largest, making square 4? That forces us to pick 3 for triangle and then 2 for circle. Because if square is not the largest, well, that would make triangle the largest, and that would be a 5. But then you'd have no way to order. Well, there is no, oh, there's the no order. Okay, let me think about that. So square is the largest, it's even. That would have to be 4, making that a 2. Yeah, okay, so I take that back. It would be 3, 4, 2, because it's the largest and there should be no order. That's how you eliminate the 5. But let's see, with that, obviously 4 would be bigger than 1 as well, but we need there to be no 1s in order to have evens. Is that still viable? Yeah, we can't have triangle being the largest if we were going to have 2 evens. Well, that's not true. I guess you could still have triangle be the largest, and it would be 5, 2, 4. That's interesting. Which one do I like more, 5, 2, 4 or 3, 4, 2? The fact that 1 is the largest. They both seem pretty specific, and I'm not sure. What about if we go back to an all odd? Obviously, we would know, yeah, obviously 1 would be the 5. So 5, 1, 3. Yeah, that would be the only case for triangle being the largest, 5, 1, 3. And then if square is the largest, then how would you know how to 1, 5, 3, 3, 5, 1? Yeah. So it seems like square, if an all odd, square cannot be the largest, forcing triangle to be the largest. But you can't have triangle be the largest. No, yeah, you still could have triangle be the largest. It could be 5, 2, 4. 5, 2, 4. Yeah, let's go with 5, 2, 4. I want to see where that takes us. 5, 2, 4. But just to double check, that first digit is odd. Yes. Triangle or square is the largest. Yeah, I picked triangle to be the largest. The sum is odd. It sure is. That's 11. There are no pairs, and there's no order. It decreases, it then increases. Okay. Well, it really just comes down to either B or C. That's all it is. Which one? Which could we deduce that there is a 1? Well, yeah, let's go. Yeah, I guess really the fact that I chose 2 evens for square and circle. Let's go ahead and test criteria card A, or sorry, B, finding out if there is a 1 or not. Okay, so yes, the Turing Machine does approve of the fact that there is no 1s. So yeah, so there are no 1s, and that does mean that we do have 2 evens. So let's go ahead and type up in our notes in B, and we'll say that the solution has no 1 digit. All right, well, let's go ahead and cross out the 1s. And remember that not having a 1 is a reason for our solution to be odd, even, odd. So then let's go ahead and cross out the remaining odds in square and triangle, or sorry, square and circle. Let's go ahead and test criteria card C, which is the largest. I can't really tell. I think there are possibilities either way. If triangle is 5, 5, 2, 4. If square is the largest with 4, then it'd be 3, 4, 2. Yeah, I can't tell the difference. So let's go ahead and retest criteria card C, figure out which is the largest. And so yes, it is true that triangle is the largest. So let's go ahead and cross out the square from being the largest. And of course it can't be 3, because if 3 is the largest, then you'd have 2, 2, and you'd have duplicates. So yeah, so it definitely has to be a 5. And because of no order, yeah, square can't be 4. So yeah, I think we got the right proposal. And then that would mean circle cannot be a 2. So it does look to be that 524 is the correct answer. Okay, so let's just review very quickly. Triangle is odd, yes. There are no 1s. That's correct. Triangle is the largest, it is. The sum is odd. Yeah, and the others were true from when we created the proposal. Okay, well, let's go verify that 524 is indeed the solution. So 524, yeah, decreases and increases. Fantastic. Well, how do we do versus a Turing machine? Well, it is a 6 criteria card puzzle, and we did 5 tests. So, you know, I think that's an excellent result. We did do ACD in the first round. C and D were incorrect. And in the second round, we did BC. We already deduced E and F, so we didn't have to test that. And both B and C were correct. So let's go ahead and type that up. So ACD in the first, and then BC. And then B was correct, and we retested C. Okay, so we beat the Turing machine by 1 question. A bit close, but still, obviously recognizing how criteria card E and F play against each other, where we can deduce, really helped out, right? We reduced these two. Not sure, maybe I missed something, maybe I rushed through it, but I think, yeah, I think I needed to retest C. But still, just keep track of what how some of these criteria cards interact with each other. Remember, they have this natural deduction that can be made, helps us solve these puzzles a little bit more efficiently. Well, what about you? How did you solve? What criteria cards did you choose? Did you notice anything interesting that you'd like to share? Add those to the comments. If you like the video, please do give it a thumbs up. And of course, don't forget to hit subscribe. Well, until next time, have a great one.